All right, folks, here is a video on week 11 Wednesday's homework problems, number 21, 22 at Reese, and number 38, okay, at Reese. Let's start with 21 and 22 over here, okay? So let's start easy. So again, the graph that's given is of f of x, okay, f of x. Now, f prime is the easiest to do, so we're going to start with that. Okay, if you're given f and you want to find some features of f prime, that's easier than f double prime. Both are easy, but I feel that f single prime is the easiest. So remember, f prime literally means slope. Okay, it literally means slope. So really, it's asking where is the slope positive. Okay, and the slope is positive at the oranges, okay, at the orange highlights. All right, so let me cover this over here so we're not distracted by the other answers for f double prime. So the slope is positive at the oranges, and the slope is positive at the oranges, and hence we have these intervals here. Okay, the slope is negative at the pink highlights, hence we have these intervals here. And the slope is 0 at basically local min maxes at the humps. Okay, which are these blue points here. Okay, now, and those are the blue points down here. Okay, 0 just means x, 0 just, well, sorry, no, 0 means 0. I'm overcomplicating it. Now, let's look over at f double prime. Okay, so f double prime, I don't want you to pay attention to these right here. Okay, because that's for f single prime. So now f double prime, we have to switch our glasses. Okay, now when f double prime is positive, we're looking at concave up. When f prime is negative is when we're looking at concave down. So when it's concave up, we're looking at the oranges over here. Okay, so the concave up, concave up, concave up, and therefore we have these intervals right here. When it's negative, we're looking for concave down, which are these highlights right here, and I forgot to highlight this right here. So the pink highlights are denoted or are related to these pink highlights on top are related to pink highlights on bottom, and those are the intervals where it's concave down. Now, when it's 0, okay, when the f prime is 0, those are the inflection points. Okay, those are inflection points, and we can estimate the inflection points to be here at the blues, and the blue points are here, right here. Okay, the blue x coordinates are here, I should say. Now, let's talk about 38. Okay. 38 is right over here. Now remember, the graph is f prime. It's not f of x. So this is a graph of slopes. Okay, these are graph of slopes. Okay, it's not f of x, it's f prime. Okay, and we have a horizontal tangent. Let's just put these as blue points here. Okay, at 1. Let's see if I messed that up. 1, 3, and 5. Yep. Okay. So remember, f prime has horizontal tangents. Now, f of x or f of regular x, okay, with no prime, when it has a horizontal tangent, okay, that's what we're used to see. That's what we're used to thinking. Now we're seeing horizontal tangents for f prime. Okay, so we're just going to take note of that and put that in our back pocket. Okay. Now, okay. Find all the values of x on the open interval where there's local minimums, okay? So local min and maxes, let's just talk about mins and max, local min max. If we look over here, okay, and ignore the blue and the green, what I wrote here in blue and what I wrote here in green, ignore that, okay? Let's see if I can make a clean diagram without those right here, without that blue and the green, because that can be a little bit distracting. Okay, let's see if I can just erase the blue and the green. Okay, that's the blue. Whoops. The blue. Boom. Okay. Let's erase the blue. Blue. Okay, let's erase those. Erase those. Boom. Boom. Whoops. Yep, no, I'm good. There. Erase this green dot. Erase that. Erase that. And let's get this out the way because I'm a perfectionist, which I'm not proud of. I'd rather not be so I can let go and not worry about little things, but okay, there we go. Okay, so now we can say that this is a local max and this is a local min. Okay, so we can say that the local max, okay, or local max, for example, here is when the slope transitions from positive numbers into negative numbers. And you can see that these are positive slopes and these are negative slopes in this hypothetical case. Okay, so again, let me repeat that. The local max is when we transition from positive slope to negative slopes. And the local min, which is what I believe I was asking earlier, okay, the local min, yes. The local min is when it transitions from negative slopes to positive slopes. Okay, so let's look over here where it's transitioning from negative slopes to positive slopes. We can see, okay, let me use a different color over here. I'll use gray. Okay, we can see that it's transitioning from negative slopes to positive slopes, okay, right at this point, okay? So at this point, it transitions from negative slopes to positive slopes. Remember, this is the graph of slopes. So at x equals to 6, we have a minimum at the f of x graph, okay? Even though we can't see the f of x graph, we can basically assume that based on what we see on this f prime of x graph, okay? So that takes care of A, it's 6, okay? There's a local minimum there. Now let's look at B, okay? B, I really want you to pay attention to this one over here. So it's concave down and increasing, okay? I think we can agree that this over here, okay, these blues, let me, just so that my highlights are consistent. I think we can agree that this whole thing is concave down. And where is it concave down and increasing? It would be at this portion. Okay, that's where it's concave down and increasing. So it's half of this pink portion where it's concave down and increasing. This would be concave down and decreasing. Okay, but we're only interested in this portion. So concave down and concave down and decreasing, concave down and increasing, okay, is this. Let me write it out. So if it's concave down, if it's just straight up concave down, that means slopes are decreasing, okay? Concave down, slopes are decreasing. Let me just change this to blue. So it's blue font, blue highlight, okay? Now, if it's, so you can see the slopes are decreasing here, 5, 4, 1, 0, negative 1, negative 4, negative 5. And now if it's concave down, okay, I'm going to change the CC to save some space. If it's concave down and f of x is increasing, then slopes are decreasing as we established, and the slopes are positive because look, this blue highlight, which is concave down and f of x is increasing, the slopes are all positive, 5, 4, 1. And slopes are positive. So again, if it's just straight up concave down, we only have one condition, slopes are decreasing. That would be this whole blue right here, okay, which is basically the pink. If we have two conditions, concave down and f of x is increasing, then it's just half of the pink, which is the blue right here. So the two conditions would create, at first, concave down and f of x increase would create two conditions for the slopes. Slopes are decreasing, which is consistent here, and slopes are positive, 5, 4, 1. Okay, in this hypothetical case, slopes are 5, 4, 1. So slopes are decreasing and slopes are positive. Let's remember that. Slopes are decreasing, and we look at the graph of slopes. Slopes of decreasing and slopes are positive is here and here. Okay, do not include this because even though this is decreasing, okay, it is negative. Slopes are negative there. So we're only interested in this, which is an interval of x interval of 0 to 1 and 3 to 4, okay, which is boom, boom. All right. Now, next up is C, which is pretty much chain rule, okay? So, okay, this is just a play on words, okay? They're just overcomplicating this. They're overcomplicating this with just wording. The slope of the tangent line at G, remember slope means prime, so slope of F is F prime. So slope of G is G prime, okay? So I'm gonna add a prime there, all right? So chain rule, let me write that down over here. So if I'm trying to find the slope of G, the generic form is gonna be this, okay? G prime of X equals to derivative of outside, leave inside, okay? And then derivative of inside, okay, like that. Now it's asking for the slope of G at x equals to 3, so I'm going to replace all the x's with 3's, okay? Boom and boom. Okay, so we just basically have to solve this, all right? Now, let's talk about f of 3, okay? Let's fill that in. That's given to you, okay? So watch this. I'm going to go like this and write f of 3 is 5 over 2. Because negative, my bad, okay, simply because of this, all right, f of 3 is negative 5 over 2. And f prime of 3, remember, this already is the graph of f prime, okay, this is the graph of f prime of x. Graph of slopes, okay, let me say that right here, f prime equals to graph of slopes, okay. So f prime at 3, so at 3, the graph of f prime says the y value is 4. Okay, so I'm going to replace this with 4. Okay, and now you just literally plug this in your calculator. Okay, or you can do this in your head. All right, because this is 75 over 4. This is 25 over 4. The 4 on the bottom cancels out with this 4. You're left with a clean 25 times the 3, which is 75. Okay, again, this 4 right here came from that y value, okay? So there you have it, folks. Hopefully that answers your questions and that is clear. Thank you for tuning in.